Alright, we're gonna show you how a hydraulic circuit works. What we're using this application for is roughly a 20-foot wind turbine, lifting it from a horizontal position to a vertical position.
Our reservoir is holding all of our hydraulic fluid, and it's going to pass through our inlet strainer by our pump that is being driven by our motor. Our motor is going to drive the hydraulic pump and pass it through our relief valve that is set to specific PSI, and it will constrain it to that PSI until we change it again. Once it passes through the relief valve, it will go through our check valve that is only going in one direction, and after that it will go to our directional valve.
And after that, when it goes through the directional valve, it's going to the pressure, which would be this one right here, is going to go through this needle valve, and it also has a check in it, so it's allowing free flow one way and then metered on the way back. After that, it's going through this pilot operated cartridge check valve, and it's going to go into the end of the cylinder, which is going to extend the rod, allowing the wind turbine to lift up. Now, your reservoir holds all your fluid, and it also acts as a fluid conditioner, cools it down, and all the contaminants will settle at the bottom and whatnot. Your inlet strainer is more commonly going to be a coarse kind of strainer. It's not going to filter anything that's very small in micrometer. After that, it's going to go into the hydraulic pump, and what that's purpose is for is to create flow. That is being spun by the electric motor, which is a 12-volt DC motor, spinning the shaft of the pump, which is allowing it to create flow. Then the relief valve, it gets set to a certain PSI, your maximum working PSI that you'd want to perform in the circuit.
Our relief valve also has a return to the tank as well, so that it can actually the extra fluid that is being passed will go to the tank that's not being used to go pass through the check valve.
And this check valve is just a device that allows fluid to go one way and not the other, kind of like a diode in a electronic circuit. This solenoid operated directional valve, which is going to allow direction in both ways in this little circuit here, and how that operates is when it gets the electronic signal, it will shift, and then this envelope right here will now become down here, and that will allow the pressure to actually go this way from here to here, and pressurize it this way to retract the cylinder, and all of your return fluid will pass through this way and back through down here to tank, back to the reservoir.
Mind you that our pilot operated cartridge is also a safety mechanism, so that when the cylinder is completely extended, it will not retract due to a load being put on it.
And how that operates is on the pressure side, from this directional valve here, if this is the pressure side, it's going to free flow through this check right here, go through, it's going to pass this check, free flow through that, and then extend the cylinder. Now on the return, when this directional valve switches and the pressure is going to be the opposite side, how this works is it's going to do the same thing here through this needle valve, go through. Now this right here, this little dash marks right here, those are pilot operated, meaning the fluid's going to go this way, and it's going to try and retract the cylinder, but it's going to build more pressure that it will actually deliver a pilot signal to this check valve to release it, because it can only open one direction. So by pressure working on here, the excessive pressure is going to go through here, extend the ball out, and allow fluid to travel back, taking this path here, going back down to the reservoir. And that's basically the whole complete circuit and how it works. I hope you enjoyed this video.